So let's take a look at how that leading coefficient could affect the end behavior. And specifically, we're going to start with this graph here where the end behavior is 2 down. I know that the degree of the function is going to be even, but we also see that the leading coefficient is a negative number. Now, if we just test this out, if I have f of x equals negative x squared, and I put in a very small value of x, let's say negative 1,000, then what I'm going to be doing here is I'm going to be squaring negative 1,000 and then taking the opposite of that. So negative 1,000 squared is 1 million, and I take the opposite of 1 million, I get negative 1 million. So I can see that as x approaches negative infinity, f of x also approaches negative infinity. And we can do the same thing for a very large value of x. Let's move on to this function over here, f of x equals x cubed, and let's just test this one out and see what happens. If I have f of x equals negative x cubed, I see that the leading coefficient is negative. When I put in negative 1,000, I'm going to be taking the opposite of negative 1,000 cubed. And so that gives me the opposite of negative 1 times 10 to the 9th, which happens to be a positive 1 times 10 to the 9th. So as x grows closer and closer to negative infinity, f of x is getting incredibly large, which is what we see happening over here. And we can do the same thing for positive values of x as well and get the same result.